All right, let's get started. Welcome to another Common Lisp Study Group. I'm your host, Ram Vedam, with Atlanta Functional Programming. Today we'll be discussing and continuing our development of our CL4th interpreter that we started a few weeks back before we ended up switching over back to completing our initial application development demo that we used to create a FLAC metadata viewer. Couple things before we get started. One, you may have recalled from our last episode when we covered this that there were some issues with our anaphoric macros that we developed as part of the AFP LOL workshop, the Let Over Lambda workshop. Those were deleted. Those were related to some reader macros that we created that were messing with the read table that it was in the Lisp REPL. I was not using at that time and did not introduce this library called named read tables to actually build some of those reader macros. I tried to retroactively go and add them in. That sort of started compiling, but then went down a route of actually having some other issues, exposed some other issues in that code to correct some things. So for today's episode, our new fourth interpreter, at least for the time being, will not actually give you the ability to inspect the fourth dictionary right now because I was unable to actually go and get some of those issues fixed to use proper read tables. Once I have that, I'll have another episode that will update the new fourth interpreter function, as you see here on line 165, to use the anaphoric and pandoric macros from there so that we can then inspect the environment as we are developing our interpreter. Additionally, folks who are watching the video on YouTube, if there are suggestions on how to maybe update the anaphoric macros to not use readers at all, I'm all ears. Primarily because I think, in general, trying to avoid reader macros unless absolutely necessary is probably good practice. As many of you probably have heard, some of our seasoned Lispers have joined our discussions. The use of reader macros, while definitely helpful for creating readers for domain-specific languages, in general for development, causes some issues with the standard reader macros that are available as part of the Lisp REPL, and you have to switch between read tables in order to actually register those reader macros into the Lisp image and switch back to the standard one whenever you're done. Otherwise, you might have some name conflict resolution that has to be addressed at some point in time when somebody is leveraging your code base. Additionally, if you're going to use custom read tables, specifying in your documentation that those read tables are there and there are potentially going to be some issues with whatever standard read tables your current Lisp image or your Lisp project is using is certainly useful for the Lisp user who's going to be leveraging your library. Otherwise, some weirdness can encounter, which I actually did encounter because I didn't realize that some libraries that I was using behind the scenes were using reader macros as well. So to give a quick review of what we did up until now, just because it has been a few weeks, I thought I'd go through this code just one more time through, so folks coming in can actually, so it reminds ourselves where we are right now. We started with a standard fourth machine, which contains a series of registers and different variables. Two stacks are involved usually in this fourth machine. One is called the parameter stack, which is labeled here as P stack. This is where parameters will be pushed until an operation is available. Is found during the parsing of a particular piece of code, at which point those parameters are then popped off, the operation is applied to them, and then the result is pushed onto the parameter stack again. Then we have the return stack, which holds the instruction of the current operation or function to execute. This is useful for if you're moving between one function and another function, having what that next operation being in the return stack will be important. In fourth, just a quick review, each function and operation, whether it be an arithmetic operation or a user-defined function, are considered what are called words. Each of these words represents a series of instructions that you can apply to a potential set of parameters that you have pushed onto your parameter stack. Fourth holds all of their words, their functions, into what they call a dictionary. A dictionary that is usually bootstrapped by the fourth interpreter, and one in which you can actually go and extend at runtime. There are two other variables here that we have not yet discussed and we'll be discussing today, and that is compiling and dtable. Compiling, very briefly, for right now, you could think of as a way of dealing with the threaded macro stuff that we've introduced a few weeks ago, where in threaded code in fourth, that means that you're actually being able to interleave between different executions, not like concurrency, where that concurrency is a different notion. Additionally, as we covered a few weeks ago, we had this idea about that there's an abstract machine that's built on top of this, and in Lisp, particularly, we're going to be leveraging concells to create what's called cons-threaded code to leverage the features of Lisp in order to implement our fourth. Very quickly, we also defined, when we first introduced this, a couple of things. One is a clear definition of what a fourth word is with respect to our fourth interpreter. That is, it contains the name of the symbol, what is the previous word in the dictionary, so we could do a reverse lookup of words in the dictionary. Whether or not the word is a compile time word or a runtime word, which for folks, words, since they're operations, if it's, it did the compile time, runtime separation, differentiation is kind of like Lisp macros. At what point in time will those be applied? Threading. This flag, again, we just mentioned it earlier. We're talking about how code is actually structured and how the indirection is going to be compiled. We also introduced a few weeks ago the different types of way of actually threading code, or dealing with the different indirections. I encourage you to go and watch that last episode, which covers these in general, in pretty decent detail about what the difference is between subroutine threaded code, indirect, direct threaded code, token threading, and cons threading. From this structure of fourth words, we created a definition of what a dictionary is. A dictionary is going to be a linked list of words in our Lisp interpreter. It will allow us to recursively go through and do a quick lookup for words, since we're going to have a small number of these words. Now, of course, as you're building your own interpreters, if you're trying to make them more and more mature and try to create some more optimized dictionary lookups, you could certainly use tree type structures for this, and so forth. But to make things simple, our fourth interpreter uses a list of words. Then we've defined our first, I guess you could say, definition of what an interpreter is. Like any interpreters in Lisp, we try to leverage the features of Lisp to actually go in and create our runtime interpreter. One is if we're applying a particular operation, if we know that that operation is a function call, then we can just use function p to define that function, and then just call the function using funcall. So that way, if you are creating operations for your Lisp interpreter, you could just simply define them as Lisp functions for the time being. Additionally, here we also talked about some of the semantics of the return stack and the parameter stack, and what is applied to where, depending upon what operations you're trying to do. For example, if you're actually trying to apply a function to an operation, you might want to take the current word, push it onto the return stack, and then continue. You could push the remaining parts of the return fourth code onto the return stack, and then you could push the operation that you're trying to call, which is probably going to be a function, has the program counter, so that when the next iteration happens, you can actually go and call it. Additionally, we've talked about until you hit an operation, you're always going to be pushing the current program counter is going to be pushing, will represent a parameter, so you're going to push it on to the parameter stack and move forward. So you could see that we're essentially just doing a lexical scan. We're just doing a linear scan across the fourth code to actually go and read in our stream. And the ending of the program is when we have no more tokens or code operations to actually go and read and then evaluate. Now, you may notice here, for folks who just are joining us, are not familiar with this particular inner interpreter thing from our last episode, very briefly, that we're also checking the return stack to see if it's null. That's because of the fact that we may want to actually, we want to make sure that we've actually gone back up the stack frame and actually applied all the return values that return instructions that we pushed onto the return stack, so that way the code itself will be completely evaluated. Just 1 second here. From here, we also very quickly defined our primitives that are in the Forth language. Folks who aren't familiar with Forth, on top of your standard arithmetic operation, the base dictionary words will contain very low-level primitive instructions like no-ops, duplication conveniences, and swaps, and so forth. So from here, we have the no-op, the standard arithmetic operations defined. We also defined some special Forth words that are commonly known for folks who are familiar with Forth. One is dupe, which is duplicating the current argument that's on the parameter stack. Swap, which will actually swap the different parameters on the parameter stack. Printing will take the current top of the stack and just print it. Dropping will actually go ahead and just pop it off and pop off whatever is currently the top level of the parameter stack and ignore it. And then a couple of operations related to pushing stuff onto the return stack when appropriate and popping off of it accordingly. And finally, we've defined how might we actually go in and leverage this Forth. And one way of doing it is we have a macro called goForth, which will evaluate our new Forth interpreter with our dictionary, and then it will just apply the words as it's going through with the Forth interpreter that we've given it. And we ended up with what we had last week, last time, which is our first new interpreter, which includes the use of dtable, which we will touch base on this today. So today we're going to actually start with two things. One, a discussion on what the author was talking about in terms of duality of syntax, because it was important in order to introduce other operations, specifically some of the stuff that we were talking about with anaphora, but and anaphoric and Pandoric macros. But more generally, it talks about the advantage of using Lisp compared to using other languages to implement some code and to develop in. Most of you who are watching may be wondering, well, why bring this up? Because we're all like we're learning Lisp for a reason, right? It's often the case that most people who are learning Lisp and learning Lisp macro programming, not knowing when to use macros is a big topic. Like when is it appropriate? And it's related to this notion that at least a book defines, although I'm not entirely convinced that this is a good explanation of it, but I'll bring it up for discussion. And that is this notion of what he calls the duality of syntax, which is the ability to essentially create a new feature in a programming language such that you could modify a given program in the language A into another program in the same language B, and the modifications required to change from A into B is smaller than trying to port A to B in a language without a feature. Now, why that is important is related to how we're going to be building up, our programs in Lisp. Oftentimes is the case that you find patterns through the course of your development that you may want to enforce through through the use of some sort of syntactic abstraction, because you don't necessarily want your users to go in and just take the same code and copy and paste, because although the structure of the code becomes familiar to them and they'll be able to knock out the same code structure, number one, it's not maintainable in the long run, because if you want to change particularly a pattern because you've encountered a better way of doing the same structure, you would have to apply it now to a lot of different places, which becomes a huge refactoring exercise. Metaprogramming, and in particular Lisp macros, give you the ability to clean all that up, to enforce a more declarative style of programming, because you'll be able to define your operations at a level at which it represents the domain in which you're applying those operations in, and it provides more context in your programs if you develop your macros correctly. And it's related to Forth, especially, and then more specifically. More specifically, the designing of interpreters and compilers in general, because often it's often the case that you are defining operations and new functional structures in your programming language that you're implementing, and you want to have the ability to enforce them in the host language as well. And sometimes you may not be able to do that if you're using a different host language that doesn't provide you metaprogramming facilities. And all Lisps, whether it be Common Lisp, Scheme, but mostly Common Lisp and schemes that provide unhygienic macro systems, will give you the ability to have more power to actually go and define these syntax transformers. So today, we're going to be discussing immediacy, D-table, and the compiling. We'll see how far we get to before we hit another roadblock. Are there questions from my review at all? And folks that are watching? Okay. let's just get started. All right, so now in our new fourth interpreter macro that you see right here, which for folks who are following along, it's essentially the implementation that's defined on page 302 in chapter 8 with some adjustments so that it uses a proper closure rather than using the Pandoric macros for the time being. You may notice that there is one hole in there that that we haven't actually filled, and that is related to implementing our primitives. Now, I've decided, instead of using the author's naming convention of fort install prims, to call it fort install primitives, just so that it's a little easier for me to recognize what exactly is happening. Oops, sorry. Just uncomment this. Boom. Uncomment this. Okay. So let's set the back quote 1 second. What am I missing here? Let's go and double check to see if I messed this up. Oh, I see here. Why is this not recognizing that it's in a back quote? I need to put. Oops, I don't think I need to do this, but let's see. Complaining about that. Yeah, that's what I thought. It is related to this guy. Let's see if this works. Read error. Let me just try and implement this. Mapcar, sharp quote, let thread equal lambda, set dictionary to be the fourth word, previous dict, make header, and thread. Ah. So we're going to have to update this. Okay, this is related to the fact that I switched this to a pure closure instead of using the anaphoric macro. see if we can go and fix this. So this function basically applies all of our primitive functions into the dictionary, and then generates the structure that we could then add. But how do we change this if we're going to not use anaphoric macros? Let's see. I think we could just go ahead and write a new version of this. Fourth install prim. Let's use this primitives. Just try here. And what this guy will do is it will take our dictionary that's in our fourth registers, you know what? It's easier just to write this in the straight code, and then we can refactor this later once we have that bug fixed. Okay, so what I'll do is, for the time being, is write this code straight in here and see if that would work. So again, let's go ahead and do a map car of the following. Let thread and this is going to be same way here, because it's going to grab it and then apply it using the kiter and that anaphoric macro A1, that anaphora that we generated. Let's see if this works. Arguments, we're just going to return that's why. That's right. We can't do that because this is going to require us to be able to retrieve everything from the dictionary. So we can rewrite this instead of doing this threaded thing. We do, what is ultimately this function doing? This function is grabbing a current primitive form. It takes the car of the form, right. Okay, I see what it's doing. So what we're going to do here is we're going to write this using, so what this function, primitive function is doing is it is taking in a function, which is in our fourth primitive forms that we've defined here earlier, these guys, and it is going to go ahead and generate what fourth expects in terms of the function. So it's no longer actually a Lisp function, it is a fourth function. And what that means is the code related to the actual function itself is in the thread, and the remainder of the information, like the label, which is what dictionary it's applying, all that's going to be populating the fourth structure before it gets added to the hash table. So let's see here. How would I write this? So I'll take lambda func. We'll call it func for the time being. And then we're applying this to fourth primitive form. Oops. Primitive forms. Okay. And technically, we may not need the prog n here, but I'm just going to go ahead and keep it in there for the time being. Let's make sure. Yeah. All right. So what do we do in this func? In this func, we create our thread, and our thread is going to be a lambda, an anonymous function that holds. It will hold the header of our func. Oops. That's not what I want to do. Let me just make sure that I'm in. That's right. So I have to get out of here and here. All right. So now here, what we do is, let me just make sure that this guy. Okay. When you do C and stuff, doing a mixture of Vim and using smart parens, sometimes it can get into an unbalanced parentheses situation. So just be a little careful. This is just my Vim skills that keep popping out whenever I'm using Doom Emacs. So here, now that we have this function, what we could do is, oops, do this. We set up our dictionary to be make fourth word. What is it? The name of it is going to be obviously the car of our function object that we just passed in. The previous is going to be whatever the dictionary con cell is currently. The immediate, and we'll talk about immediacy in a minute, but if you can imagine what this function is doing here, it is essentially going to be taking the code that's related, the body of the function, and passing it into the immediate flag. And then the thread is our object, the lambda that we just created earlier. So that's that. So that's a dictionary. We've updated dictionary, but now we also need to add this to our global dictionary, our D table. And the D table we'll talk about in a minute. We'll just do this. Set F thread D table. And we apply, what is it? Header function. You know what? I'm going to do this. I should have named this right. Yes, func phone. So now this should be okay. This should actually grab all of our primitive forms and then load them into our dictionary. Let's see. Comma, not inside of the back quote. So this is the same issue that we had earlier. But this time we won't have any problems with the anaphoric problems. So we'll be okay. Sorry. Let's see what this is. This is in a lambda function that's being generated by... Oh, I see. This is because we're already out of unevaluated states with the first splicing operator there. May not beat this. Let's see if this causes any issues. I don't believe it will, but we will see. Because this should be treating the function object as a list instead of an application. Let's see. Comma, not inside of a back quote. I'm assuming that it's talking about this guy. Line 9. Column 43. Oh, this guy. Two warnings. What is the warnings? Undefined variable detail. Got it. So this is coming from the fact that we are using dtable here from our fourth registers and doesn't recognize them. Let me see how this is getting macro expanded. I'm going to put these guys back. I'm going to try something here. So I don't think this is... Got it. This is what I needed. I was missing that one back quote from earlier. And just noticed it when I was reading that code. And let's see here. Undefined variable fun. Undefined variable fun. I just defined it here. we even need to have a sharp back quote here? I don't think so. What is this complaining about? Sorry, not that one. I'm just seeing where fun is all being used. It's all within the scope of this map car, so I don't think that that would be a problem, but says so that's going to be in. That I have to actually go and unquote some of these guys. Let's see here. This is in the I can't find it. Do I need to actually go and create? Oh, that's right, because this is a freaking anaphoric macro. The state of the object is not available, so that means I have to go and create a gens. Alright. Let's see here. Things you have to do in order to get to work around lack of anaphora. One way of doing this is let's see. How can I go and fix this? This will be related to what do I need to do to put this in there correctly? That would require you have to do this. You already do this. See if this will work. do this here, but I may have to. Let's see. Come on, it's a back road. That is right. This is already a back road. This is called back road. Undefined variable. Fun. Where is that happening? That's happening in. So let's see what happens when we go and macro expand this guy. Fun is still fun. What's defined here? Let's see if I can get this. It's gonna complain. How am I supposed to get fun into? You know, it might be just easier just to fix that anaphoric problem and then use that to implement this. Yeah, let's go ahead and do that. Because I'm wasting. I think this is going to be a waste. You guys are seeing real-time coding here. I'm going to change up my design a little bit here compared to what was in there. Figure out what is going on if I do this and see if this is going to complain. Okay, this is compiled and loaded, but this guy will complain because we don't have our comments out of a back quote, and that's because we shouldn't be actually but is that an error or is that a warning? That is an error. Why is that causing an error? Let me see what the book is saying here that I'm missing out. Let's see. Select dictionary. Previous dictionary. Missing here. Let's go ahead and fix this for a second here. This will require me to go back to my ASD file, bring me the fourth demo. Here. Workshop. Error somewhere, and that was compiling the Pandora macros. That's fine for the time being, because I am going to use macros. What's it called? Undefined macros. Remove dispatch function. That's related to the fact that I can't find the read table on line 62. Let's go ahead and do that. Folks just tuning in, I am trying to re-add my AFP-LOL workshop library back into our fourth interpreter so I can actually leverage our Pandoric macros that we've introduced about a year back actually when we went through some of these macros. I recommend you guys go through those lectures and those videos before you come back and take a look at this video. Otherwise, this is going to confuse you a little bit. I will not be going through the details of all this Pandoric stuff for the time being. Said that it can't find it in line 62. Let's look at something to see if there's any calls. Okay, so since I'm using the read table here, do I need to? I'm forgetting right now. Do I need to actually go and specify the namespace of this? I don't think so, because I already said in read table reader macros. Let's see. Let me see if it can be auto-completed. Oops. This is already defined in this is already defined in our reader table, which is defined here. Let's go and look at this. This is using could be because when I evaluated defined reader tables and set it up so that dispatch macro character is sent \5. Then we just went ahead and added the reader into the read table using dispatch macro character in case of all case. Can we do something here? Let me see something. still not giving us that. Okay. Back to this guy. Let me try and explain what I'm trying doing here so that folks can understand where I'm getting stuck at. Maybe I can figure out some of this stuff through the process of explanation. So basically, there's an issue with loading up this third-party library, as I mentioned earlier. This is from our Pandoric macro series. And originally, our Pandoric macro series followed what was kind of considered to be, at the time, based on my understanding, the kind of a practice in the book where it's leveraging a reader macro to grab in a stream of variables, and it would generate the let bindings for you automatically. So if you guys take a look, originally in I think it was in chapter 5 or chapter 6 where he defined this sharp backquote. What it did was it just generated a parenthesized version of variable with the binding associated with it. We would be leveraging that just so that we can actually go and create our bindings automatically. It makes things a little bit easier for creating each of the individual word bindings that are necessary to be passed into the dictionary during object construction, as you saw earlier in the new fourth interpreter, where we were grabbing each word in our dictionary and then creating the appropriate fourth word for the final interpreter to use. Unfortunately, one of the issues with using reader macros, as you can encounter, as you're seeing here, is the dispatch table is having some trouble getting applied. A few weeks ago, thanks to one of our Lisp regulars, I fixed one of the issues related to actually using this third-party library called name read tables that allow us to define our own reader tables and compile and use them in our own libraries when you use an evaluate when, an eval when, sorry. Thanks to Richie Primus for that help. There still seems to be an issue related to this dispatch function lookup, even when the in-read table is being used, which is kind of odd because of the fact that we're not using any other read tables in our function. And we're actually, if you saw what I showed you earlier in read tables, what this is doing is it's actually defining our read table, and it's merging the current read table into it, so we don't have any symbol mismatches, and the existing symbols that are defined in the current read table are available. And we've defined our dispatch function here. But for some reason, it might be because I'm using also an eval one in here. So earlier I added this. This may not be necessary. Let me do that. Okay. Let's see. Let's see what this is. We may have gotten past that. Yes, we did. Now we're getting a different error saying that. What is this? It's saying that Pandoric let is undefined, defined earlier but not available at compile time. During macro expansion of Pandoric let, what line number is it actually causing an error? Is undefined, defined earlier in the file, not available at compile time. That does not make any sense to me. Let's see. Why would it not be available at compile time? Oh. So the code in question is the example of actually using the Pandoric let in the accumulator here. Let's see here. Why is that causing an issue? Says that is not available. Just the way macro expand let binding transform is not available. Let's see if let binding transform. Unloaded. Error calling the dispatch function. Of course, the error is calling the dispatch function. Right here. Why is this causing that issue? It says that it's undefined. Never had this error before, so I'm surprised that it's giving me this error now. Yeah, once we fix this, some of the other code in the fourth project will actually all work just like a charm. But unfortunately, I have to go and fix this first. This guy still. Okay. Okay, so these guys don't need to be here anymore. Set F symbol blend test content error. Macro expansion of Pandora Colette. Wait a second. Did I just fix the... Oh, I fixed part of this problem by just recompiling. Just go ahead and do... This is a bit of a dirty hack right now, primarily because I would have to figure this out so we can actually get this into load time, but to keep things moving, I'm going to try and see if I can just use in read table here macros. Okay. See if this works. Works. And macros do not exist. Line 166, column 26. Ooh, okay. So oh, this is good news. Okay. Go ahead and do this. And read tables. In read table current. And so Richie, that thing that we saw a couple weeks ago with the reader macros, it looks like if I read it in the REPL and set it to the REPL, this all loads correctly. Guess we should have tried that first. Okay, so line 166. Let's do this. AFP dot. I'll write shorter. Macros. What? I'm just gonna rename this guy here. Sorry, anaphoric. And give it this. because that has to be a key argument. And comma inside of a backquote line 79. Okay, so we're back to where we started, but at least our interpreter is actually compiling now without any warnings. Okay, so now why is this sucker giving me trouble? Let me see if I could actually go and move this guy. And let me see. I may have done something wrong with the translation of this. Is correct. So let me see if I yank this guy. Let me go ahead and paste it here. And move this. Interesting. So this guy seems to not like it here, but if we do this here, it's complaining about comma not being inside of a backquote. There's a bug in this guy. Let me go look at the errata. There might. Aha! He is using a sharp backquote rather than a sharp quote. That's what it is. That's why. Okay. It's like, what the heck? Alright. I think I gotten this all in. This looks like it's working. Let's go and see if I could do a macro expand of here, and then we can do a code review. A1 is still unbound. What the hell? There we go. All right. Now we can actually review this. Okay. 1 second. I need to get a refill. Sorry, folks, my throat's been dry. All right, so what did we do here? First, we fixed, well, I somewhat fixed the anaphoric macros and Pandoric macros issue, one of which was related to compiling using our reader tables to our read tables to hold the reader macros that we're using to actually generate both our anaphoric macros, the ALET percentage sign, which if you recall when we talked about anaphoric macros, what it does is it's capturing the environment into a variable that you could then use. So it's kind of violating what's called lexical transparency in the sense that it's violating lexical scope and kind of inspecting the internal environment to grab the information it needs. In languages like C or C++, or even modern language, other dynamic languages like Python and so forth, this notion of lexical scoping and being able to introspect your environment to grab symbols and information about symbols doesn't exist. And Common Lisp gives that to you. I defer you to our videos on anaphoric and Pandoric macros to give some of that. Additionally, what this does is it provides us the ability to also grab, especially with Pandoric macros, the ability to access the actual abstract registers, and then we could change the ability to instead of using multiple closures in our fourth environment and inspect each individual closure through accessors that we provide in the closure itself, P-lambda gives us the ability to go in and treat it as a single environment and then be able to access our abstract machine and the registers in the abstract machine directly. So what this new fourth interpreter does is, as you can see in the macro expansion, is it's grabbing all of our machines, registers, p-stack, the parameter stack, return stack, program count, and so forth. It sets the D table. The D table is something that we're going to be talking about in just a minute here. It's related to, though, the compilations of the actual fourth code. And it's treated as a hash table for now. And what we do is we then use the thread variable, which as I mentioned, is related to how we're evaluating a particular fourth function to grab the rest of the code related to our current program counter. As you saw here, it's actually setting the the lambda to being the drop function, not the drop function. Sorry, the first default of our environment, and we go through and actually take each of our individual our individual words in our fourth primitive form dictionary, and we are attaching them to this global dictionary in the fourth environment. So what this is doing is a process called bootstrapping. It is grabbing all of our primitive operations, sticking them into what would be considered to be your global fourth environment, and then setting up the appropriate program counter so that we're ready to actually go and interpret code. The one weirdness about this that might be interesting to folks is this format here. What is exactly this doing? Well, when you're generating each operation, like in this case here, this is actually the expansion of the map car. So each one of these let, as you saw before, is what was it? It is space m collapse. What is collapse? Let's see if I can do that. Yeah. All right. So if you recall before, what this is doing is it's taking this lambda function here, and it's generating a new let binding for each one of them, which is a piece of code that will just go through and grab the operation in the primitive forms dictionary, and it gets the body of the function, which we saw, and it not only generates the new fourth word, but it will also stick it into this D table, this hash table, and that's what we saw here. If we look at the expansion, this map car is taking each operation, whether it be drop, like we saw here, it would, or even, let's say, pushing something onto the return stack. It's grabbing the code, sticking it into this this thread lambda, and then it's creating the hash for that thread lambda in the D table, and then setting it to those instructions. Now, what this is doing is it is creating the interleaving structure for a concept that Forth calls immediacy, and this is Forth's way of doing metaprogramming. So it requires to describe how traditional Forths work a little bit, so you could see what this code is actually doing. So I'm going to briefly explain that. And traditional Forths, you have normally some sort of variable is something that keeps track of whether or not we're in regular interpreting state or in metaprogramming state. If the variable is zero, it can be zero or non-zero. We're basically saying that we're going to interpret this operation in regular interpreting state, and that basically allows them to essentially do a lookup, find the operation if it exists, if it's a user-defined operation, and just do normal what Forth does for function evaluation, which, as I mentioned before, was pops off the parameters, applies the function, pushes the return onto the parameter stack, and moves on. If it's non-zero, though, it's doing something a little bit different. It basically goes into a metaprogramming state and expands until it starts grabbing. It comes to a state where it's no longer actually, generating new code. So it could then, go back to normal evaluation. How would this kind of work in our thing? So, well, let's go ahead and, create a new Forth interpreter here. Let me first define, before we move forward. A second here. I'm going to go ahead and grab predefined here? I should have. Yeah, I do. Okay. We first define two things here. Diff on fourth. Right now, I think these are macros later in the book, but right now I'm gonna, for the time being, I'm just gonna go ahead and define these guys just briefly as dummy functions so that we don't get that warning if we end up causing any issues. Okay. Just, and this. Okay. So now, where is this being defined? Oh, that's through the macro expansion, isn't it? That's fine. We'll see what happens when I do go forth. Fourth, new fourth. Try this. 1, 2. This is the example from the book. Just going to go ahead and say example from chapter 8. So what we've just done is we've actually, this go forth guy, like I said, it allows us to execute the code in our new fourth environment, and it does a once-only evaluation. With this, we can actually then call our Pandoric macro. Do I have it defined? No, I do not. Excuse me. Actually, I'll do this. Folks, do not do this at home. I'm basically grabbing something specific from the Pandoric macros thing because I've forgotten to export it. That is, what was it? It's called with Pandoric p-stack for. Let's go into p-stack because we want to go and grab this just to make sure that we know what we're looking at. We generate this guy. I don't think this is going to compile, but it won't actually show us anything. I'm going to have to go and paste it here so we can actually see it. And let me go and increase that. Pandoric is nil. Interesting. Guess this did not do what I thought it would. Let's go and macro expand this guy. Phone call grabs it. Tag body phone call with 5 to 90 W. I know what the problem is. This interpreter here is not actually sticking our. It's not evaluating this phone call. Aha. It's this function that's causing this problem. Compiled and loaded. Undefined variable this. Without that this, we won't be able to call the function. How do we do this? This one. This is related to the the fact that the a let is not actually giving us the this variable. It's not being bound. Otherwise, it should have worked. Okay, so that's a different error message, so I'm going to have to go and take a look into that. Let's see what the generation is. This is not being generated. Got it. Because that is bound locally, and we haven't exposed. Okay, this is not cool. Okay, I know what to do to get this working, but this needs to be cleaned up a little bit. If I just do this, I know this will work. And for macros, that's what this is. This is that. Still nothing weird. It's a closure. Let's see, what does this do? So, what is causing this issue? The only thing I could think of is what this does. It's grab new for if, and then it does a macro let. Get Pandora. So let me do something here. Since I recompiled this guy, I could just go and do it forward. And let me see if I can actually go and inspect this guy. Oh, so this is our dictionary. Got it. This is our hash table generated. But our parameter stack and everything is not defined. Got it. Weird. Why is that not happening? That must mean that although we defined it here, sorry. Oh, that's right. It's because we did not implement fourth handle found and fourth handle not found. We need to implement fourth handle found and fourth handle not found. We could just simply do this. The fourth handle found temporarily to be this fourth inner interpreter. What? Shift. Fourth inner interpreter. Loop con blah blah blah. PC. That is simple. That machine. Did I accidentally forget to put the hash code in there too? Nope. Okay. Let's see if I can do this. This looks like a pretty disgusting thing to do, but you know what? We'll see. Undefined, but never used. Of course it's not. This. Cannot. Objects of type functions cannot be dumped into facile files. Warning, but that's fine because of the fact that these are defined later anyway. Here, and the new fourth interpreter, do that, and Still no. It needs to execute that function. Let me see. That's fine. Going to So like I said, fourth handle found and fourth handle found not found technically are macros. They're not functions. Earlier I was trying to stub them out as functions. I'm going to go ahead and change these to macros because this is actually generating code that's calling other macros. So and what is the warning? There is a warning. Oh, got it. Unintern. For handle. Unintern for handle not found. Because I've defined these as functions before, you're going to get some errors if you compile it like this. So now this is a kind of what we were seeing earlier. And done. Okay, and let's go ahead and do this. Now if I go in and create this, I should be able to go and expand this. PC is not found. Unbound. Okay, why is program counter unbound when I see it right here? So these are layers of macros that we're seeing here. So to get them to work together, we have to make sure that we follow certain things. Sorry, I just realized that I don't need this anymore. I'm going to clean that up so I can add this back into version control when I'm done. Let's see what happens if I do this. Is a macro, not a function. Yes, that's right. Why is that causing some issue? Alright, let's see here. Can't find the program counter because of the fact that this is compiling. This is compiling. Let's see if I can do this. This is not compiling. Which I could do this. If I do this, and I do this, it generates this. Okay, so this should all now have the access to the program counter, whereas before it was not. Okay, let me see if that works. This, if I still no. Why? Should have actually went ahead and generated those. Okay. You know what? I bet you this is going to correct itself when we leverage first a couple things. Go ahead and correct this here. This is going to be fixed into that. So what I'm doing now is I'm exposing with Pandora because we're going to need this. So okay, so I'm going to have to reload. Oops. I'm going to have to reload our workshop stuff. But I can reload it through the fourth demo. Fourth handle is a macro, not a function. Where is it called? Okay, so that is being called somewhere. Fourth handle. Yeah, this might be still caused by the fact that I accidentally compiled those as functions instead of macros. So give me a second, I'm going to just quickly reload. I'm going to end up having some potential trouble here just because of what I had to do to get this all working. Let's see though. Workshop. It's going to complain about the Pandoric macros at some point. Didn't. Wow, fantastic. Let's go and do this for the demo. Let's see what happens. New variable fourth is unbound. Where am I calling new fourth? New fourth. Ah, there it is. Right here. Put this here. Why am I not surprised? On line 170. Sorry. I have to also specify here name read tables in read table, because we're leveraging this guy. I forgot to change here. This is a kind of a standard pattern. If you use named read tables, you may want to keep track of the read table that you're replacing. Since we're currently just using the standard read table, where I'm switching between what we defined in AFP LOL workshop, which defines that sharp backquote reader macro that we need to do some of our let binding transformations with the standard one, which I did as well. If you look at the Pandoric macro Lisp file as part of the AFP LOL workshop package. So this should, there we go. Cool. Restart just to make sure one more time that everything's working. It looks like we're heading on a little over 2 hours here. My apologies for folks watching late internationally. But sometimes that's what you're going to do. Now, ideally, since this got compiled, I should have in set package AP4th. We have a closure already defined. There's still an issue with our environment, so moving forward might be at this point a little bit. I need to go and fix some of this in order to actually get this, in order to move forward in our discussion of what Forth is doing. So I'm gonna stop at this point just for the time being. I'm going to briefly mention a couple of things before I let you guys go in terms of concepts that we're going to be covering. One of which is the compiling flag that we haven't actually touched yet. This is actually what's needed in order to implement fourth handle found and fourth handle not found more fully featured than what we currently have here, which is just simply starting our fourth inner interpreter. The other thing is there's a couple things related to that flag, which is used for compilation that we need to create, and that's a couple of fourth primitive functions for defining it's for defining compilation state, like in terms of the control flow and actually controlling the compilation when you're compiling Forth code. There's two specific operations there that we need to still add, which we will talk about next time. These are new Forth primitives for immediate and not immediate, turning on immediate mode and not immediate mode. So whether or not we're in metaprogramming mode in Forth or not in metaprogramming mode. And then we can move forward in our discussion on the specific handler functions that we defined here to actually go in and create our first, I would say, running version of the interpreter. But like I said, until I go and fix this one issue here with my Pandoric macro not being able to inspect the environment, I can't can't really move forward here. So there's a bug in my code that I need to really dedicate some time to actually go and fix. I will go ahead and check in all this code in GitHub on the AFP project page, on the Atlanta FP project page. This will now work both the well, it'll compile. Whether or not it will work is a different story. But hopefully by the time you guys check it out, I'll have those updates too as well. Are there questions? Okay, my apologies. Thought we'd move a little forward faster than this, but as with all interpreters and compilers, sometimes there's the goal that you want to actually go and accomplish, and then where you end up being after a certain time box. So hopefully next week we'll have something to give you guys, some more meaningful things to show. And then we can actually get started writing some real Forth code, and then we can go from there. So thanks for joining. I'll see you guys next week. We're going to be continuing this project. Actually, sorry, not next week. Next week is 4th of July weekend here in the United States, so I will be having that. That's a time off. We're going to have a little bit of a repeater week. So I will see you the week after that. That is, what is that date? That is the 11th. I'll see you guys on the 11th of July, where we're going to be continuing this project. I'll see you guys later. Thanks for joining.